January 2016. Two astronomers at the California Institute of Technology sit down in front of a room full of journalists and say something that sounds insane.
Taking a look at Caltech tonight, the California Institute of Technology.
Appearing together in a magnificent planetary alignment. Neptune is the faintest in appearance. Neptune are all gathering in the sky this week. We've got something for you.
They say there is a planet in our solar system that nobody has ever seen. A world 5 to 10 times the mass of Earth, orbiting the Sun once every 10,000 years, so far away that the most powerful telescopes on Earth have never caught a single photon of light reflecting off its surface. They can't show you a photograph. They can't point a telescope at it and say, look. What they can show you is the math. And the math, they say, is screaming. Konstantin Batygin and Mike Brown didn't find Planet 9. They found its shadow, a gravitational fingerprint pressed into the orbits of the most distant objects in the solar system. Objects so far from the Sun that they take thousands of years to complete a single orbit. Objects that should be drifting randomly through the frozen outer dark. But they're not drifting randomly. They're clustered, aligned, herded into orbital patterns that, according to every simulation Batygin and Brown ran, should be statistically impossible without something massive pulling the strings. The probability that the clustering was a coincidence? Less than 1 in 10,000. That was 2016. In the decades since, the evidence has piled up. New objects have been discovered that fit the predicted pattern. Simulations have been refined, the estimated mass has been adjusted, and in the last 12 months alone, 3 separate developments have converged in a way that has pushed the Planet 9 hypothesis from theoretical speculation to the threshold of confirmation. A new object has been found that shouldn't exist where it is. An infrared signal has been identified in data spanning 23 years, and the most powerful survey telescope ever built has started searching. Something massive is hiding past Neptune, and the math, which has been pointing to it for a decade, just got a lot harder to ignore. But to understand why this matters, you need to understand what the outer solar system actually looks like, because it's nothing like the tidy diagram you saw in school. Past Neptune, beginning at roughly 30 astronomical units from the Sun, lies the Kuiper Belt. 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles. The Kuiper Belt stretches from 30 to roughly 50 astronomical units, a vast ring of icy debris left over from the formation of the solar system 4.6 billion years ago. Pluto lives here, so do thousands of smaller objects, frozen relics that never accreted into a planet. Most of them orbit the Sun in roughly predictable paths, nudged and shaped by Neptune's gravity. But beyond the Kuiper Belt, in the region past 150 astronomical units, something strange happens. A handful of objects have been found on orbits so elongated, so extreme, that they swing out to distances of 500, 600, even 1,000 astronomical units from the Sun before looping back. These are called extreme trans-Neptunian objects, or ETNOs, and their orbits don't make sense. The first one found was Sedna, discovered in 2003 by Mike Brown himself. Sedna's orbit is extraordinary. Its closest approach to the Sun, called perihelion, is 76 astronomical units. That's already far beyond Neptune, but its farthest point, aphelion, is roughly 937 astronomical units. It takes Sedna approximately 11,400 years to orbit the Sun once. And here's the critical detail. Sedna's orbit never brings it close enough to Neptune for Neptune's gravity to have pushed it there. Something else did. Something further out. Something nobody has found. In 2012, another object like Sedna was discovered. 2012 VP113, with a perihelion of 80 astronomical units and an orbit so elongated it reaches out to roughly 450 astronomical units. Same pattern, same inexplicable distance from Neptune. Same question, what put it there? When Batygin and Brown analyzed the orbits of these objects and several others like them, they found something that made them sit up. The orbits weren't just extreme, they were physically clustered in space. Their long axes pointed in roughly the same direction. Their orbital planes were tilted in a similar way. It was as if something had gathered them, corralled them, locked them into a formation that defied random distribution. They ran simulations, thousands of them. They modeled the evolution of the outer solar system over billions of years with and without a hidden planet. And the results were definitive. Without Planet 9, the clustering dissolves within a few 100 million years. The objects scatter. The alignment disappears. The odds of the current configuration existing by chance are vanishingly small. But at a single planet, roughly 5 to 10 times Earth's mass, on a highly elongated orbit with a semi-major axis of several hundred astronomical units, and the simulations reproduce exactly what astronomers observe. The ETNOs cluster, they stay clustered, and the math works. The simulations also predicted something else, and Planet 9's gravity wouldn't just cluster distant objects, it would actively inject objects into unusual orbits closer to the Sun, producing a population of low-inclination, Neptune-crossing trans-Neptunian objects with clustered perihelia. When Brown and Batajan looked for these objects in the observational data, they found them, exactly where the simulations said they should be. And then, in July 2025, the case got stronger. A team of Japanese astronomers using the Subaru telescope on Mauna Kea, Hawaii, announced the discovery of a new object in the outer solar system. They nicknamed it Ammonite. It was only the fourth sednoid ever found, a member of the rare class of extreme objects whose orbits keep them permanently beyond Neptune's gravitational reach. Ammonite was discovered near its perihelion at roughly 71 astronomical units, with a semi-major axis of approximately 252 astronomical units. Dr. Fumi Yoshida, who led the survey, confirmed that Ammonite is too far away from Neptune for major gravitational influence. Neptune didn't put it there. Something else did. Dynamical analysis of Ammonite's orbit produced a striking result. Statistical tests indicated that it may share a primordial orbital grouping with Sedna-like objects dating back approximately 4.2 billion years, with over 97% confidence in the alignment. 4 objects, 4 independent discoveries made over 2 decades, all pointing in the same gravitational direction, all screaming the same message: something is out there. But here's where the story takes its most dramatic turn. Because while astronomers have been hunting for Planet 9 by looking at the objects it influences, a separate team has been looking for the planet itself. Not with optical telescopes, with infrared. The logic is elegant. A planet 500 to 700 astronomical units from the Sun reflects almost no sunlight. At that distance, the Sun is a dim point of light barely distinguishable from other stars. An optical telescope would never see it, but the planet itself, even at the frigid temperatures of the outer solar system, would still radiate heat. Faintly, in the far infrared, and 2 space telescopes launched decades apart have surveyed the entire sky in those wavelengths. IRAS, the infrared astronomical satellite, launched in 1983, and Akari, launched by Japan in 2006, 23 years between them, long enough for a slow-moving planet at 500 astronomical units to shift its position in the sky by a measurable amount. In April 2025, a team led by Terry Longfan of National Tsinghua University in Taiwan published a study in the publications of the Astronomical Society of Australia describing exactly this search. They estimated the expected flux and orbital motion of a planet between 500 and 700 astronomical units from the Sun, with a mass between 7 and 17 Earth masses, then searched the IRAS and Akari catalogs for pairs of infrared sources whose positions shifted by the right amount over the 23-year gap. They started with the full catalogs, millions of sources. They applied positional criteria, flux quality filters, angular separation limits corresponding to the predicted motion. They narrowed it down to 13 candidate pairs. Then they inspected the images by hand. 1 candidate survived, a single infrared source detected by IRAS at 1 location, absent from the same coordinate in the Akari image 23 years later, and a corresponding Akari source detected at a different location, absent from the IRAS image 23 years earlier. The angular displacement between the 2 detections, approximately 47.5 arc-minutes, matched the predicted motion of a slow-moving planetary body at that distance. The infrared signature suggested a temperature between 28 and 53 Kelvin, consistent with an ice giant similar to Uranus or Neptune, but far colder, far more distant, and far more alone. Fan's team was cautious. They stated explicitly that the IRAS and Akari detections alone are not enough to determine the full orbit. They need follow-up observations. They need at least 9 detections to evaluate a linked Keplerian orbit. But the fact that a candidate exists, that it was found independently of the orbital clustering evidence, that its estimated mass and distance fall within the range predicted by Badigan and Brown's simulations, is the closest anyone has come to actually detecting the planet itself. And now, the biggest gun in the history of survey astronomy is pointed at exactly the right patch of sky. The Vera C. Rubin Observatory achieved first light in June 2025 and began full survey operations later that year. Its 3.2 gigapixel camera photographs the entire visible southern hemisphere every 3 nights. Over its 10-year mission, it will catalog billions of objects, track every change in the sky, and detect faint, slow-moving objects in the outer solar system that no previous telescope could see. Planet 9, if it exists at the distances and brightness levels predicted, falls within Rubin's detection capability. Badigan himself has said publicly that he believes Rubin could confirm Planet 9's existence within the coming years. And just this week, June 2026, a new study published in Science Daily complicated the picture even further. Researchers analyzing the dynamics of distant trans-Neptunian objects found that some exhibit more stable orbital motion than the Planet 9 model predicts. The study doesn't disprove the hypothesis, but it suggests that if Planet 9 exists, it may be much farther away than originally thought, weakening the gravitational influence and explaining why some objects appear less disturbed than expected. The mystery, in other words, isn't resolving, it's deepening. Now let's talk about what Planet 9 would actually be if it's real, because this isn't just about finding a dot on a photograph. This is about rewriting the history of the solar system. The leading models describe Planet 9 as a super-Earth or sub-Neptune, an ice giant somewhere between the mass of Earth and the mass of Neptune. It would have a temperature of roughly 30 to 50 Kelvin, about minus 370 degrees Fahrenheit. It would orbit the Sun on a hugely elongated path, taking between 10,000 and 20,000 years to complete a single orbit. At its closest, it might approach to within 200 or 300 astronomical units. At its farthest, it could be more than 1,000 astronomical units away. And it would be invisible, not hidden, invisible. Too far away, too cold, too faint, reflecting too little sunlight for any telescope in history to have noticed it. But here's the question that makes this story genuinely unsettling. How did it get there? One possibility is that Planet 9 formed closer to the Sun, in the same region where Jupiter and Saturn grew, and was gravitationally ejected early in the solar system's history during the chaotic period when the giant planets were still migrating and rearranging their orbits. In this scenario, Planet 9 was born as a 5th giant planet, a sibling of Jupiter, Saturn, Uranus, and Neptune that lost the gravitational lottery and was flung outward into the deep freeze. It didn't escape entirely. The Sun's gravity held it, but barely, in a vast, elongated orbit that carries it far beyond the Kuiper Belt, into the cold and the dark. Another possibility is that Planet 9 was captured, stolen from another star during a close encounter in the Sun's birth cluster, billions of years ago, when the Sun was still surrounded by sibling stars close enough for gravitational theft between systems to occur. In this scenario, Planet 9 isn't even ours. It was born around another star and has been orbiting our Sun as an adopted alien ever since. A third possibility, proposed by some researchers, is that Planet 9 doesn't exist at all, that the orbital clustering is a statistical artifact, a product of observational bias, introduced by the fact that we can only observe certain parts of the sky at certain times of year, and we tend to find objects in the directions we look most often. Several studies have challenged the clustering significance, arguing that when you correct for these biases, the pattern weakens or disappears. But the infrared candidate doesn't care about observational bias. It was found in an all-sky survey, and Ammonite doesn't care about bias either. It was found in a region of sky with no preferential observing history. The evidence is converging from multiple, independent directions. And here's what makes this different from every other hidden planet story in the history of astronomy. Planet 9 was not predicted by a mystic. It was not hypothesized by a crank. It was proposed by two of the most respected planetary scientists in the world, using the same gravitational mathematics that predicted the existence of Neptune in 1846. Neptune was found because Uranus's orbit was being perturbed by something invisible. Astronomers calculated where the perturber should be. They pointed a telescope at those coordinates, and Neptune was there. The same mathematics is now pointing past Neptune, past the Kuiper Belt, past everything we've ever photographed, into a region of space so distant and so dark that a planet several times the mass of Earth has been hiding there, in plain gravitational sight for the entire history of human civilization. The Sun's gravitational influence extends more than 160 times further into space than Neptune. That means the solar system is vastly larger than the tidy 8-planet model suggests. And somewhere in that enormous, unmapped space, objects are being herded, clustered, and shepherded by a gravitational force that can only be explained by mass. Enormous mass, hidden mass. Mass that has been sitting in the dark for 4.6 billion years, shaping the architecture of the outer solar system from a distance so extreme that humanity didn't even know there was anything out there to shape. The Vera C. Rubin Observatory is scanning. The infrared candidate is awaiting follow-up observation with the DE-CAM instrument on the Blanco telescope in Chile. The simulations are running, the math is tightening, and the list of objects whose orbits make no sense without Planet 9 grows longer every year. Something massive is hiding past Neptune. It's roughly 5 to 15 times the mass of Earth. It's between 500 and 700 astronomical units from the Sun. It's cold, it's dark, it reflects almost nothing, and for 10 years it has been bending the orbits of everything around it while remaining completely, maddeningly invisible. The math hasn't stopped working. The math is working perfectly. That's the problem. Because the math keeps pointing at something that should be there, in a region of space where we've looked and seen nothing. Either the math is wrong, and every simulation, every clustering analysis, every orbital anomaly, every sednoid, every infrared candidate is a coincidence, or the math is right, and there is a planet in our solar system that nobody has ever laid eyes on. A world larger than Earth, older than civilization, colder than anything we've ever touched, orbiting the Sun in silence, in the dark, at the edge of everything we know. And if the next few years of observation confirm what the mathematics has been saying for a decade, then the solar system you grew up learning about, the one with 8 planets neatly arranged in a disk around a yellow star, was never the whole story. It was just the part we could see. The rest has been out there the entire time, waiting for us to do the math.